Hi guys, we're going to go over page 12 on Unit 2. So we're going to be talking about interpreting and using function notation here. Okay, so our intro problem. Here is a graph that represents function f, which gives the height of a drone in meters t seconds after it leaves the ground. Decide which function value is greater. Okay, so again, we have this function f that we're going to be talking about here that's giving us the height of a drone, and that drone's going up and getting higher and higher each time. And then we have this t meters after it leaves the ground. So we have those two ideas there. So if we go with those ideas, we have a function here. So the function idea, and then we have a time that's also given to us. And so that's what we're looking at. And remember that function is giving us the height of the drone. So as soon as I see that f of, really it's the height of the drone that's representing. So it's not 0, but this is saying the height of the drone at 0 seconds. So at 0 seconds, the height of the drone is at 0. So this f of 0 is equal to 0. And then f of 4, so the height of the drone at 4 seconds, if I go to 4 seconds and I find that on the graph, that's at about, if we label these 1, 2, 3, 4 meters off the ground, then that's telling me that f of 4 is equal to 4. So if these are the two values of these things, then f of 4 is the one that has the greater value. And that's what we're trying to figure out there. So if we continue along with that idea, f of 2 would be the height of the drone at 2 seconds. So the height of the drone at 2 seconds is at 4. And f of 5 would be the height of the drone at 5 seconds, which is also at 4. So which one of those is greater? I'm just going to write that they are the same because that's exactly what they are. Okay, so those would be equal to each other. If we look at the next one, we have f of 3. So the height of the drone, remember that's what the f means, the height of the drone at 3 seconds. So the height of the drone at 3 seconds is at 4 as well. And then the height of the drone at 7 seconds, way over here, is all the way back down at 0. So my answer to this one that's greater would be the f of 3. Make sure you understand that I am not just simply circling the one with the bigger number in it, because the 3 and the 7 are the number of minutes or seconds, and the number that we're really looking at there is the height of the drone. Now, this last one makes you think a little bit. F of t and f of t plus 1. So t is just any arbitrary time, and t plus 1 means that time plus 1 second. So we have to think about this in terms of the graph. And if f of t was, if t was 0, if that was the case, and then this would be 1, then we would be finding the height of the drone at 0, which is 0, and the height of the drone at 1, which is, it looks like it's at 2, and those aren't equal. So that doesn't work out there. So we're looking for values to where the t value and then the next value are the exact same. So if I look at it, I'm pretty sure it's happening up here. Now, there's a little bit of a mistake that's going to be made, and that is that a lot of people will say that t can be from 2 to 5, okay? So t can be 2, yes, because if t is 2, then t plus 1 is 3, and both of those values are at the same height up there. T can also be 3, because if t is 3, then t plus 1 is 4, and both of those have a height of 4, okay? T can also be 4, and then t plus 1 is 5, and both of those have a height of 5. But if t was 5, then the height is 4, and then 5 plus 1 is 6. That height is no longer 4. So that's why we can't have that at 5, because that doesn't work, okay? So my t values that are going to work here, if we just look at the numbers, would be 2, 3, and 4, okay? But this graph is connected, so that means that we're going to connect everything here. And so I need to give an interval. And so this interval here, the t values, okay, that are between 2 and 4 all work. And that's inclusive of 2 and 4. And I could maybe say between and including 2 and 4, so that we have those in there. If you want to write that in interval notation, it's going to look like a closed bracket, 2 comma 4, a closed bracket. And then you can kind of go from there. But the idea, the concept is there with number 4. Okay, if we move on to example problem number 2, oops, we don't want to do that. If we move on to example problem number 2, I got to find my scroller here, you guys. There we go. The function w gives the temperature and height the temperature in degrees Fahrenheit of a pot of water on a stove T minutes after the stove is turned on. Okay, so we've got this idea. If I want to go through this, we have the function that's here, that's W, and W is giving the temperature. So it's giving me a temperature, okay, in degrees Fahrenheit of a pot of water on a stove T minutes. So there's our other one there, T minutes after the stove is turned on. So if I want to write this out, what this is going to look like is W is the function of T, and that's going to give me the temp of the water. So T is the minutes, and then I'm just going to write temp here. So essentially that's the concept of this whole problem here. So if we go with that, W of 0 equals 72, we're explaining the meaning, okay? So this is saying the temperature of the water, okay, that's what the W is that's there. So we got the temperature of the water. And then our next part to this is going to be at the time, okay? So the temperature of the water at 0 seconds, minutes, I'm going to get the right units here. Sorry, we switched back and forth. At 0 minutes. And then we're going to have this last part here, which is equal to 72, and that's actually giving us our temperature is 72 degrees. Okay, and you can even degrees Fahrenheit there to be correct. Okay, so that's the idea of what we're doing. Now, I'm down here, I'm going to graph it. So I'm going to graph kind of as I go. So W of 0 is equal to 72. My input is 0, my output is 72. So I'm going to go to 0, 72. So because it's by 50s, then there's 25 in between. So 72 is going to be right below this. Okay, and I'm also going to put like a little a next to this just so I know that part A is what gave me that, and I've graphed it, so I'm going to put a little slash through it. Okay, now we're going to do the same thing with some of these. So this is where it gets a little interesting. You're like, okay, wait, we have a greater than symbol. Make sure you know that that's what it is. So how do we do this? Well, the W means the temp of the water. Okay, and then you do the 5. So at 5 minutes. And now it's not telling us what it is, but it's telling us is greater than. And then we repeat that. W means the temp of the water at, and then 2 minutes. So that's what we're given there. So we know that we have a greater than there. Now there's a lot of things we could do with that. We're going to come back to this one when we're graphing, so I'm not going to graph that one quite yet. The next one we have W of 10 is equal to 212. So the temp at 10 minutes, okay, again, the temp is that W, and then at 10 minutes there is 212 degrees Fahrenheit. So I'm going to come over to 10, and I'm going to go way up to 212. So remember, this middle line is 225, so 212 is going to be right in the middle of that, and I'm going to put a little C above it. Again, I'm just trying to mark that that's what I've done on the graph so we can kind of see what matches up with what. Okay, so we've got that one done. Now, W of 12 is equal to W of 10. So the temp, that's what you say for the W, at 12 minutes is, in this case, equal to the temp at 10 minutes. Okay, now normally I wouldn't graph this, but in this case, I have the temp at 10 minutes in here, so I should be able to put the temp at 12 minutes. So at 12 minutes, we're also going to be at that 212 that's up here. And again, I'm going to put a little d up there because I've graphed that one on the graph. Okay, so we're good with that one as well. If we keep going from here, let's see, W of 15. Okay, so back to one that's like B. So hopefully you have the idea of this. So the temp, and again, I'm talking the temp of the water. So the temp of the water at 15 minutes, okay, so think about that, is, in this case, we're talking greater than the temp. Again, so the temp is coming from this W that's here. So the temp at, and then we're talking the 30, so at 30 minutes. Now I'm going to look at this at 15, I don't know, and at 30, I don't know. So I don't know exactly what that is. I'm going to come back to that one on the graph as well. And then lastly in here, we have W of 0. Okay, so the temp is the W. At the 0 is 0 minutes. Is, in this case, that's a less than symbol. So is less than. And then we do it again, the temp, because that's what the W is, at 30 minutes. Now, if I come over here, W of 0, oh, we have that one. So we know where that one is. And all we know is that that's less than W of 30. So there's actually a lot of places I can put W of 30. So I'm going to come over here to 30, the input of 30. And I just have to make sure that this point is above here. Okay. Now, one other thing I'm going to do right now is that we know that water boils at 212. We know it's probably not going to get much higher than that. So I'm going to leave my points smaller than that, but I'm just going to pick a random point out here. And I'm going to put it there and I'm going to label that F because that's what I got. But again, you could have your F in other places. So I have that one graphed. Okay, if we come back to the ones that we skipped, W of 5 is greater than W of 2. So I don't know anything about 5 and 2. Even down here, I don't know about it. So I just have to make sure wherever I plot 5, and again, I'm going to follow the same thing that I'm not going to go much higher there. So wherever I plot 5, let's say I plot 5 right here, and then I plot 2. Now 2 is not on this line, that's 2.5. So wherever I plot 2, it's got to be below that 5. So I can make it really close, I can make it really far away, whatever, it doesn't really matter. But wherever I do that, and again, I'm going to label these B just so I know where they came from, but that's labeling those. Okay, the last one, again, I'm color coding these. W of 15 is greater than W of 30. So at 15, it should be a higher temp than it was at 30. So if I put 30 here, I have to make sure my 15 is somewhere above that. Now, I could have it in line with C and D if I wanted to, or I can have it off of it. And whatever I do, again, it's going to be in there somewhere. The last thing I'm going to do, because I'm sketching a possible graph of this, is I'm going to connect the dots because this water doesn't just magically jump in temperatures and it doesn't skip over time. It goes ahead and goes through here. Now, I could, as I'm graphing these, not use straight lines here. I could also curve it if I needed to. Okay, so we've shown where everything goes. We've shown our sketch there, and we've gone through that. Thanks for bearing with me here.